High voltage readings at the socket of a high-pressure sodium fixture are not normal when the line voltage is 120 volts. The voltage at the socket should be close to the line voltage. Readings of 153 volts and 160 volts suggest a problem within the wiring of the fixture component. Possible causes include loose connections where a wire is not securely fastened, or a faulty component such as the ballast. Addressing such voltage discrepancies is crucial to ensure safe and efficient operation and prevent potential damage or hazards. When troubleshooting high voltage readings in high-pressure sodium fixtures, it's important to follow a systematic approach. Firstly, verify the line voltage to ensure it is indeed 120 volts. Use a calibrated voltmeter to accurately measure the voltage at the power source feeding the fixture. Fluctuations in line voltage can sometimes mimic problems within the fixture itself. Secondly, inspect all wiring connections within the fixture and in the junction box supplying power to the fixture. Look for loose wires, corroded terminals, or damaged insulation. Tighten any loose connections and replace any damaged wiring or connectors. Poor connections can create resistance, leading to voltage drops and potentially elevated voltage readings at the socket. Thirdly, examine the ballast. The ballast is a critical component of a high-pressure sodium fixture responsible for regulating the voltage and current supplied to the lamp. A failing ballast can cause a variety of problems, including high voltage, flickering, or complete failure of the lamp. Check the ballast for signs of damage, such as cracks, leaks, or burnt components. Use a multimeter to test the ballast's input and output voltages, comparing them to the manufacturer's specifications. If the ballast is not functioning correctly, it should be replaced. Fourthly, test the lamp. Although less common, a faulty lamp can sometimes contribute to abnormal voltage readings. Try replacing the lamp with a new one of the correct wattage and type. If the voltage readings return to normal after replacing the lamp, it indicates that the original lamp was the source of the problem. Fifthly, check the capacitor if applicable. Some high-pressure sodium fixtures utilize a capacitor to improve the power factor and reduce energy consumption. A failing capacitor can cause voltage fluctuations and other problems. Inspect the capacitor for signs of bulging, leaking, or other damage. Use a capacitance meter to test the capacitor's capacitance, comparing it to the manufacturer's specifications. If the capacitor is not within the specified range, it should be replaced. If, after performing these checks, the high voltage readings persist, it is recommended to consult a qualified electrician. An electrician has the expertise and equipment to diagnose and repair more complex electrical problems. They can perform additional tests, such as insulation resistance testing, to identify hidden wiring faults. It is important to prioritize safety when working with electrical systems. Always disconnect the power supply to the fixture before performing any inspections or repairs. Use appropriate personal protective equipment, such as insulated gloves and safety glasses. If you are not comfortable working with electricity, it is best to leave the task to a qualified electrician. In addition to the immediate safety concerns, addressing high voltage readings in high-pressure sodium fixtures can also improve energy efficiency and extend the lifespan of the components. When a fixture operates at an abnormal voltage, it can consume more energy than necessary, leading to higher electricity bills. It can also put stress on the ballast and lamp, causing them to fail prematurely. By resolving the voltage problem, you can optimize the fixture's performance and reduce its operating costs. Furthermore, regular maintenance of high-pressure sodium fixtures can help prevent future problems. This includes periodically inspecting wiring connections, cleaning the fixture to remove dirt and debris, and replacing lamps and ballasts as needed. By proactively maintaining your lighting system, you can ensure its continued safe and efficient operation. Remember that working with electrical systems can be dangerous. If you are not qualified to perform electrical work, it is always best to consult a professional electrician. They can safely diagnose and repair any electrical problems, ensuring the safety of your property and its occupants. High-pressure sodium fixtures are commonly used for outdoor lighting applications such as streetlights, parking lot lights, and security lights. They are known for their high efficiency and long lifespan. However, Like all electrical equipment, they can experience problems over time. By understanding the common causes of high voltage readings and following a systematic troubleshooting approach, you can effectively diagnose and repair these problems. It's also important to consider the specific characteristics of high-pressure sodium lamps and ballasts. These components have unique electrical properties that can influence voltage readings. For example, high-pressure sodium lamps require a higher starting voltage than other types of lamps. The ballast is designed to provide this high starting voltage and then regulate the voltage to the lamp's operating voltage. If the ballast is not functioning correctly, it can cause the lamp to operate at an abnormal voltage. In addition, high-pressure sodium lamps exhibit a phenomenon called end-of-life cycling. As the lamp ages, its internal resistance increases, causing the ballast to deliver a high voltage to maintain the lamp's light output. This can eventually lead to the lamp cycling on and off as the ballast reaches its maximum voltage limit. End-of-life cycling is a normal part of the lamp's lifespan, but it can sometimes be mistaken for a wiring or ballast problem. When troubleshooting high voltage readings, it's important to consider the age of the lamp and whether it is exhibiting signs of end-of-life cycling. Furthermore, be aware of potential compatibility issues between lamps and ballasts. High-pressure sodium lamps and ballasts are designed to operate together as a system. Using incompatible components can lead to performance problems, including high voltage readings. Always use lamps and ballasts that are specifically designed for use with each other. Refer to the manufacturer's specifications to ensure compatibility. In summary, troubleshooting high voltage readings and high pressure sodium fixtures requires a systematic approach, a thorough understanding of the components, and a commitment to safety. By following the steps outlined above and consulting a qualified electrician when necessary, you can effectively diagnose and repair these problems, ensuring the safe and efficient operation of your lighting system. Remember that electrical work can be dangerous, and it is always best to err on the side of caution. If you are not comfortable working with electricity, leave the task to a professional. They have the knowledge, skills, and equipment to handle electrical problems safely and effectively. If the voltage readings fluctuate erratically, it could indicate a loose neutral connection somewhere in the circuit. A loose neutral can cause voltage imbalances, leading to some fixtures receiving higher than normal voltage while others receive lower voltage. If you suspect a loose neutral, it is important to have it checked by a qualified electrician as soon as possible, as it can be a fire hazard. When checking connections, pay close attention to the terminals where the wires connect to the ballast, lamp holder, and other components. These terminals are often prone to corrosion or loosening over time. Use a wire brush or terminal cleaner to remove any corrosion and tighten the terminals securely. If the terminals are badly corroded or damaged, they should be replaced. Another potential cause of high voltage readings is voltage feedback from other equipment on the same circuit. If there are other devices connected to the same circuit as the high-pressure sodium fixture, they could be injecting voltage back into the circuit, causing the voltage at the fixture to rise. Try disconnecting other devices from the circuit to see if the voltage readings return to normal. If they do, it indicates that one of the disconnected devices is the source of the feedback. Once you have identified the source of the feedback, you can take steps to isolate it from the high-pressure sodium fixture. This may involve installing a filter or using a separate circuit for the offending device. Also, consider the ambient temperature around the fixture. High-pressure sodium fixtures are sensitive to temperature, and their performance can be affected by extreme heat or cold. If the fixture is located in a hot environment, it may be necessary to provide additional ventilation to prevent overheating. Overheating can cause the ballast to malfunction, leading to high voltage readings. Conversely, if the fixture is located in a cold environment, it may take longer for the lamp to reach its full brightness. This is because the lamp's internal pressure is lower at colder temperatures. However, cold temperatures should not cause high voltage readings. If you are experiencing problems with high-pressure sodium fixtures in cold environments, it is important to consult the manufacturer's specifications to ensure that the fixtures are suitable for the operating temperature range. Regular cleaning of the fixture's reflector can also improve its performance. The reflector is designed to direct light downward, but it can become coated with dirt and dust over time. This can reduce the fixture's light output and efficiency. Use a soft cloth and mild detergent to clean the reflector, being careful not to scratch the surface. In addition to the above troubleshooting steps, it is also important to keep accurate records of any repairs or maintenance performed on the high-pressure sodium fixtures. This will help you track the performance of the fixtures over time and identify any recurring problems. Include the date of the repair, the nature of the problem, and the steps taken to resolve it. Also, keep records of any lamp or ballast replacements. This information can be valuable when troubleshooting future problems. Remember that high-pressure sodium fixtures are just one type of lighting technology. There are many other types of lighting available, such as LED, fluorescent, and metal halide. Each type of lighting has its own advantages and disadvantages. When choosing lighting for a particular application, it is important to consider factors such as energy efficiency, light output, color rendering, lifespan, and cost. LED lighting has become increasingly popular in recent years due to its high energy efficiency and long lifespan. LED fixtures consume significantly less energy than high-pressure sodium fixtures, and they last much longer. However, LED fixtures typically have a higher initial cost than high-pressure sodium fixtures. Fluorescent lighting is another option for many applications. Fluorescent fixtures are more energy efficient than incandescent fixtures, but they are less energy efficient than LED fixtures. Fluorescent lamps also contain mercury, which is a hazardous material. Metal halide lighting is similar to high-pressure sodium lighting in terms of light output and efficiency. However, metal halide lamps have a better color rendering index than high-pressure sodium lamps. This means that they produce a more natural-looking light. When selecting lighting for a particular application, it is important to consult with a lighting professional. A lighting professional can help you choose the right type of lighting for your needs and ensure that the lighting system is properly designed and installed. A well-designed lighting system can improve safety, productivity, and aesthetics. It can also reduce energy consumption and operating costs. So, it is worth investing in a quality lighting system that is properly maintained. Finally, always remember to recycle old lamps and ballasts properly. Lamps and ballasts contain hazardous materials that can pollute the environment if they are not disposed of correctly. Contact your local waste management company for information on how to recycle lamps and ballasts in your area.